Okay, Algebra 2 skills number 11, solve quadratic equations by completing the square. So this is a technique which does a nice little trick for us, because when we work with quadratic equations, we often have x squared and x at the same time, and they get in each other's way if you're trying to isolate in a traditional equation solving sense. So we learned the square root method, which says if I only have one visible x, I can just isolate that squared part and take the square root and go that way. But what complete the square does is it alleviates that problem of having x squared and x. It sort of puts them together in a roundabout way. You can't combine them, but there's a special way through factoring that you can make two x's become only one visible x. And in short, it takes an equation that cannot be solved with square roots and makes it into an equation that can be solved with square roots. That's the sort of the special technique of completing the square. The method is quite lengthy. You first want to make sure that x squared has a 1 coefficient. Secondly, you want to move the constant term away from the variables. Okay. Third, take half the coefficient of x, square it, and add that number to both sides, which seems very random. We'll talk about that significance in a bit. Step 3 sets up step 4 for you. And then once you've done that factoring, you're ready for the square root method. You've successfully transformed a non-square root problem into a square root problem. Okay, so for our first example, we're going to just look at the number you would add to both sides of an equation. Okay, we're not going to actually solve here. So we've got x squared plus 12x equals 9, clearly a quadratic equation. Here we have a leading coefficient of 1, we're good there. We have the constant away from the numbers, we're good there. It's that step 3 we want to concentrate on. We want to take half the coefficient of x, which is 6, and square that for 36. That's the number you would add to both sides. Now the significance of 36 we'll get to, but a lot of times they'll just ask you what should you add to both sides. Just make sure you're a 1 here, and you don't even have to worry so much about this. You just take half of that number, 12 in this case, which is 6, and then square for your answer there. Now we're going to take that same equation we're actually going to solve for example 2. So that same equation, okay, and again you have x squared and x together, so we can't take square roots, but we're going to change that. We're going to do exactly what we did in example 1. We're going to first make sure there's a 1 here, make sure the constant's on the other side, take half of 12, which is 6, we're going to square that and get 36. Now we add it to both sides, and you are perfectly within your rights to do that because I did something to the same, to both sides of the equation, so we're still in balance. Now what we just did there, what's so special about that 36 is it is rigged in such a way that 36 is a perfect square. It's the square of something. 6 times 6 made that 36, but that 6 came from taking half of something. So the significance there is when 6 is half of something, that means if 6 is added to itself, it makes the 12. So I've rigged this to factor in a special way. What multiplies the 36 and adds the 12? Well, that would be 6 and 6. 6 times 6 is 36. We made sure of that. 6 plus 6 is 12. We made sure of that. So it factors in this way. And notice the colors for a moment. That green there, whatever half your x term is, always shows back up in this fashion. It's helpful to know that because this is not always easy to factor, especially when we start dealing with fractions. And on the other side, of course, is 45. If you take the square root of both sides, it's now the square root method because you have x, only one visible x. It went from 2 x's to 1 through that special factoring. If I take the square root of both sides, I'm not actually showing the square root here, but it becomes x plus 6, and the square root of 45 would be plus or minus 3 root 5. Remember the plus or minus from the square root method. And then you just finish that by subtracting the 6 from both sides. So again, we went from 2 variables to 1. Now complete the square can be quite adventurous, as this third example illustrates. So here we have a quadratic equation, which later you're probably going to do the quadratic formula here, but we'll illustrate sort of the complexities of completing the square. I'm going to do the first 2 steps together. We've got to make sure there's a 1 here, so that means that I've got to divide by 3. We also want to make sure this constant gets moved away from the variables. So I'm going to do that at once here. I divided everything by 3 to make this 1x squared, 5x, and 7/3. Unfortunately, that doesn't divide evenly. I then subtracted 7/3 over. Okay, so now I'm ready for step 2, which unfortunately is also a bit of a pain here because I've got an odd number. So half of 5/2, well, that's just 5/2, and if I square it, it's 25/4. So I add that to both sides of the equations. It's already looking pretty crazy. And luckily, we can take advantage of the fact that we know this 5/2 is going to show up in that squared form. So I can factor this in as x plus 5/2 squared. Now I've got a bit of a mess on this side. And you could just take a calculator and add those two together. But I'm used to just making those the same denominator. Negative 7/3 is negative 28/12. 25/4 is 75/12. Let's go to the next screen here. That combines the 47/12. Now, despite how crazy it looks, we are ready for the square root method. There's only one visible x. So I isolate the squared part. It's already isolated. I take the square root of both sides. Again, I didn't show that. And we kind of get into a bit of a rabbit hole of simplification here. When you square this, it becomes the square root of 47, and 12 simplifies to 2√3. We have that plus or minus operator. Okay, if you're familiar with rationalizing the denominator, we don't want a radical down there, so we multiply top and bottom by the square root of 3. Let's carry that same thing over here. That makes 47 times 3 is square root of 141. Square root of 3 times square root of 3 is positive 3, which times 2 is 6. And then we finally move over our negative 5/2 for our final answer. So it can be quite adventurous. Complete the square, though, is helpful for as it is where the quadratic formula comes from. You need that skill. And plus, it'll be helpful later when you deal with conic sections in pre-cal.